everyone, welcome back to my YouTube channel. In this video, we will learn about the UV-Vis analysis, determination of intensity of the transmitted light. In a UV visible spectroscopy analysis, a 0.05 molar of chemical compound is thoroughly analyzed. The molar extinction coefficient, the epsilon, of the compound at its maximum absorption wavelength 300 nanometer is 1.5 times 10 to the power of 3 liter per mole per centimeter, and the path length of the cuvette is 1 centimeter. Determine the transmitted light intensity passing through the sample. Alright, so the first step is by using the Beer-Lambert law. So absorbance is equivalent to epsilon Bc, and you were asked to calculate what is the absorbance. So in the question, you were given the value for the epsilon, which is equivalent to 1.5 times 10 to the power of 3 liter per mole per centimeter, and your path length is given in the question as well, which is 1 centimeter, and the concentration is given as 0.005 molar, which is equivalent to mole per liter. So from there, we will get the absorbance is equivalent to 7.5. So what is the unit for absorbance? Supposedly there's no unit, so we will check centimeter here, and then we have per mole, and then here mole. So liter, this one is per liter. So indeed they have no unit for absorbance. Right, so next up we are going to change from the absorbance to transmittance. So absorbance is equivalent to negative log transmittance. So we are going to use this value here to convert back into transmittance. Alright, so since we know what is the value of the absorbance, so we are just going to plug in this value. So you will get your transmittance should be equivalent to 3.1623 times 10 to the power of negative 8. So since the absorbance have no units, so that's your transmittance. So in transmittance, we can say it is equivalent to the intensity of light that is being passing through the sample, and the incident light, which is 100%, we assume. So therefore what we want to calculate is the intensity of the light passing through, which is the intensity of exit light. So it's equivalent to your transmittance itself times to the initial intensity. So initial intensity is supposedly 100%, so it is equivalent to 1 times the transmittance itself, which is 3.1623 times 10 to the power of negative 8. Therefore we will say that the intensity of light passing through the sample should be equivalent to 3.1623 times 10 to the power of negative 8. So this is the final answer for this question. Thank you so much for watching this video from the beginning till the end, and I'll see you again in the next video. Goodbye.